there, CPO here, and I want to talk a little bit about multimeters and multimeter calibration. So one of the things I'm working on doing is checking out some battery chargers and looking at the ability to adjust the calibration on the chargers themselves. And for me to be able to do that, I need a reliable multimeter to be able to check voltages on both batteries and then compare it against what the battery chargers are reading, because battery chargers can tend to be wildly variable in how they read the voltage, and thus how they handle the cutoff voltage as far as overcharging or undercharging, depending on what you're doing. So as I'm going through that, I'm thinking, man, I need a reliable multimeter. Well, the easy way to go do that is to go out and buy a $300 Fluke or some other calibrated multimeter. And I'm exaggerating. You can get them for less than $300, I'm sure. Point being is that that's not what I have. I have a Harbor Freight special. It's a CenTech P37772. Got a great deal on it. It seemed to be a little bit better than my other multimeter which I've had, which is this little doodad here. I got it at an auto parts store, I don't know how many years ago. I would easily say probably 15 or 20 years ago. This has been the multimeter I've always used. I upgraded to this one mostly because it looked cooler, to be honest with you. I don't know if it's actually any better at all, but it's newer. Like I said, I got a great deal on it. I think it may have even been like free or $15 or something crazy like that. But what I want to do now is test to see how accurate it is. Now, the right way to do that is to get a known voltage reference source. And what that means is you can get calibrated circuitry. You can buy as low as like $35, I believe. You can get a 5-volt reference doodad that will emit a constant known voltage that you can then check against your multimeter. And that's basically how you test the calibration of a multimeter, is test something that you know the voltage to be exactly. I don't have anything like that laying around. I could send it off to get calibrated, but again, this is a $15 multimeter, so I don't really want to spend any money on it. And I'm not dealing with rocket surgery here. I just want to get close enough to feel comfortable that with a little bit of variance, of course, that my electronics components, the charging components, are operating the way I expect them to. So with that said, I did some research, a lot of research on the internet, and I've heard a lot of things. One of them is that, if you take the multimeter and you set it to ohms, and the highest level, and you touch the two probes together, if it reads 0, then your multimeter is calibrated. Well, okay, that seems a little bit weird to me. I mean, I get it. I mean, if a multimeter has a built-in calibration circuitry that will, when this happens, it will go through and calibrate itself, well, that's great. Something tells me it's not that easy. Otherwise, why would we spend so much money to have our equipment professionally calibrated? So with that said, if I take this old multimeter here, do the same thing. Let me set it to some ohmage here. Set it down. See, I'm at a 1.1, 1.2. All right, so maybe it's not calibrated, and although seriously, if I rub these together, these rusted old prongs, I get a different reading. So I am seeing something different here between the two, but I just don't think that's enough. I don't feel like that's enough. Some of the research I've done also suggests, and it's a very common suggestion, is that an easy reference source, is a Duracell AA battery. So what I found out, interesting enough, and there's a lot of documentation published on this, Duracell actually put out white paper on their batteries. But essentially, the idea is that with a 1/4 watt load, brand new Duracell battery right out of the package should be at 1.6 volts. It's rated at 1.5. That's a nominal voltage. And the idea is that right out of the package with a 1/4 watt load, it's at 1.6. Well, to test it without a load, people seem to say, you know, if you just use the multimeter with no load, the voltage is generally going to be 1.64. And so that's a fairly known data point that a lot of people seem to reference, 1.64 for a brand new Duracell battery. So I thought, hey, what the heck? Maybe I'll just start with that. I'll do a check against this battery and see what I get. The other thing that I've heard is that regulated power supplies, such as computer power supplies that power your hard drives, have a regulated 12-volt power rail, and it's regulated to a 5% variance. So it's got to be accurate, plus or minus 5%. That's still quite a bit of variance, if you ask me. But that means if you check your multimeter on a 5-volt output from a computer power supply, you should get anything between 12.6 volts and 11.4 volts. Anything in that range. That's a pretty broad range though for me. So anyway, so let's take this Duracell battery. I just got a package of 4 of these, so pulled them all out, and I want to just do some checking here and see what kind of readings I'm getting. And we'll use that as the baseline. So, .6345, 1.635. All right, let's try another one. Let's see how consistent the batteries are first. 1.636. 1.635. 1.635. All right, so one thing I did learn is that there may be some truth to this fact that these batteries are a fairly constant source of voltage at a known voltage. What I'm not getting is 1.64. I'm getting 1.635. Now, is 0.05 going to make a huge difference? No, probably not. But heck, this is fun anyway, so let's just keep rolling with it. Let's check and see what the other multimeter comes up with. Just real quick for fun. I'm going to set that to the 2000. Get my pluses and minuses here. 1.627, so it's much different. 1.627, 1.628, 1.627. So I can already tell you, I'm going to remove this one because this one's always one more than the other. So these three are always the same, no matter what I use. But the point is, none of them are hitting 1.64, which is what I want to be at. So then the question is, now what do I do about it? Do I just have to calculate math in my head that says, hey, I know that when it's supposed to be 1.64, it reads 1.635, and I have to do math? Or is there something I can do about it to make this multimeter read what I think it should be reading? So, of course, I like to tinker, so I wasn't going to settle for doing the math. I wanted to see if I could adjust this multimeter. So let's take it apart. All right, first thing I'm going to do is power it down, pull out my ports, my probes here. Now what you do want to look at, now first of all, this is not for the faint of heart. This will void your warranty, which I would never do a warranty on this anyway. It costs more money to ship it than it's worth. But just note, when you start taking things apart, you risk breaking them, destroying them, making them worse off than they were when you started. The other thing is, again, I don't even know if this is going to help me or hurt me. In my head, it's going to make me feel better, so that's why I'm doing it. So anyway, let's pull the plastic or the rubber backing off of this. Set that aside. Flip it over, and we've got 3 screws, and I happen to have a Phillips screwdriver handy. Now, I am not an electrical engineer. I am just a hobbyist, a tinkerer, and I like to mess with things. So if this is wrong, you can't sue me, because I'm going to tell you, don't do it. Don't do this at home, folks. I am not a trained professional. I don't know what I'm doing, but I'm having fun anyway. All right, so I pull off the back, set my 3 screws aside. This is what I get, okay? So you've got a fuse in here for your voltage input protection. You've also got a 9-volt battery. Now, it's really important to make sure your 9-volt battery is good when you start doing this, because if your battery is low, you're going to get crappy readings anyway. How do you know your battery's good if you don't know your multimeter's good? Well, I don't know. That's a funny question. Anyway, this is a brand new battery. I already know that for a fact. So, but if you don't know that, check it out. So then, now that I have this, and oddly enough, we can see a model number on the circuitry here. M9508. And we can see some other things like Mastech M9508-1. Mastech 9508 is actually another brand of multimeter. So the CenTech, whatever this is, P37772 is the same thing as a Mastech 9508. Just different brand on the front. So anyway, interesting item of note. All right, so in order to take this out, what we need to do is open up the display, because that's going to have to slide through just like that. And basically what you want to do is just pull it out like that. Okay? These may fall off. No big deal if they do. They just slip on. You just got to remember what order. Yellow, white, black, red. That's the order they go in. So if they pop off, just slip them back on there. So now basically what I've done is separated the main board, the internal circuitry, from the shell. So remembering I had it set where I wanted it before I pulled it off, because now I don't have access to change it because my knob is here and not there. So make sure you get that done before you pull this off, otherwise you'll be measuring the wrong thing. So with it out, we powered up. It works just the same. As a matter of fact, I can come in here and plug back in my leads in the same place I had them before. Okay, and let's check this battery here. .634 or 5, depending on the moment. So it's reading the same thing as we had before. All right, so now that I have this, I need to figure out what I need to do to calibrate. Now, the back of this will say that there are no user adjustable parts in here. It says this instrument contains no operatable serviceable parts. Screw removal by qualified persons only. Warning: to avoid shock, remove inputs before opening, close cover before use. This is dangerous. Please don't do it. If you don't feel comfortable, don't do it. Seriously, I don't recommend, even if you do feel comfortable. Don't do it. It's dumb. Go buy a really good multimeter and don't worry about it. So anyway, I'm going to keep messing with it. So what I found here in doing some poking around is on this board there are several variable resistor pots. So as you can see, right here we have a VR1, we have a VR2 pot, right here's a VR3, VR4, VR5, VR6. Those are all variable resistors, which means you can adjust them. So what I know is one of those is going to be what I need to move to adjust the voltage readout on the screen. Which one is it? That's a great question. I know the answer only because I did this by trial and error, and I got really lucky on my first go-round. I started looking for spec sheets on multimeters, trying to figure out if there's any documentation at all. I couldn't find anything, particularly about this type of multimeter. I did find some others that were kind of talking about adjusting the voltage, calibration by playing with VR1. I saw something on another one that said something about VR3. I don't know if there's a standard or not, but I figured, what the heck, I'm just going to start playing around, and I'm going to play with VR1. So I figured I would just try it, see if it did anything. Worst case is I'm out some money if I screw my multimeter up. As it turns out, VR1 turned out to have a little bit of value to it, because that's the one that ended up making the difference for me. So let me get this so you can see the screen and VR1. Alright, so the other thing is, now that I have, I know what I want to adjust. I want to adjust VR1 back there. I know that I'm going to adjust against my as close to known input voltage as I can, which is this AA battery. What I want to do is tape those leads down so that I don't have to worry about moving around on me while I'm working. So I've just got some Scotch tape laying around here. This is really low rent, so you guys that deal with electronics on a regular basis are probably thinking I'm amateur hour, crazy, stupid, dumb, whatever, and you would be right. But this is what I do. My wife would agree with you. So basically, I'm just going to tape these leads down so that I know that they're touching and I don't have to worry about them coming undone in the middle of this. Alright, so there we go. I've got my input voltage, I've got my multimeter. If I turn on my power, I've got my 1.635. So, what I want to do is get that to say 1.640. That is going to make me feel really comfortable. Whether or not it's of actually any value or not, I don't know. So, what I found is the screwdriver. These things have like a little rivet in the bottom, and what kind of looks like a Phillips head screwdriver externally. The problem is with that little rivet, you can't get a really sharp Phillips head screwdriver in there, so you kind of need a blunt one. So let me see if I can find a blunt Phillips head screwdriver really quick. So here's what I found that worked out best for me. This is a strange little tool in my micro screwdriver kit. I don't even know what kind of shape it is. It's kind of like a diamond shape. Anyway, you can use a little flathead, would work in there okay. But you just need something that can get in there and kind of turn that gently without having to worry about that little rivet that's sticking up in there. So I'm going to use this little tool here. The key is you don't want to touch anything else on the board other than the pot. And it's very sensitive. You can see I'm already at 1.632 just from messing with it. It's very touchy. So what I'm going to do is just kind of work this until I can get it to stabilize at 1.64. And that's what I'm going to do. Now, I've had this thing running for a little while to stabilize on its own. And that seems to be an important part of the process. But I'm not going to let it run for, 30 minutes or whatever. And you can see, just by moving around the board, I get some variation in readings. So, I mean, this thing is a little bit sketchy already, but let's get it as close as we can. .64. It's a little touchy, but I got it settled in there. Alright, so now I've got a 1.64. Let's try reading some of the other batteries. Make sure I get the same thing with my other reference batteries. Alright, so here's another one. Oops, positives and negatives lined up. .64. Let's check another one. That one's reading a little bit high, but that may actually be one of my higher. I can't remember now which one was which. I think that might have been the one that was one higher anyway. So let me go back through these guys again. .64, 1.64, 1.6, it hit 4, there you go. And then this one should be 1.641. Yep, it's one higher. So, basically what I'm looking at is, in theory, a calibrated multimeter. Calibrated as well as I can do it with whatever reference I happen to have with me. And you can see when I don't have anything connected, it is back to 0. So it's not like I tweaked it so now it starts out at a different setting other than 0. At least with this multimeter, it's self-zeroing. If I power it off, power it back on, let's check it again. 1.64, 1.64, 1.64. So, I think I'm in a good spot. Now, that was really finicky right there, that little pot. So, what I hate to do is put this whole thing back together and have it just wiggle and be off again. So what I think I'm going to do is apply just a little bit of hot glue, just to tack that down right where it is. I think that that'll be a viable choice for preventing this from getting out of whack again. So let's do that. All right, so there we go. I just went ahead and tacked this down really quick. I did put my battery back on. The last thing I wanted to do was hot glue it in place and then find out it was off again when I did that. So this is with it glued in. And you can see the hot glue over that pot. Just basically a light tack to the board so that it won't like rattle loose or something like that. I think that's probably good enough. Just basically holds it in place, and then I can always pop that glue off if I need to make any more adjustments. So that's it. Now I want to put the thing back together, and then I'll retest when I get it back together. Alright, so I got my back on, put the little rubber protective backing on, and put my leads back in, power it up, and let's see what we get here. Oops. 1.640. 1.640 to 41. 1.640. 1.639 to 40. So, yep, we're still good to go. Let's go back to the ohm setting. Still get zeros. So I don't know. I'm thinking that this might have gotten me where I want to be. So hey, listen. I said it before. I'm not an electrical engineer. I don't have any clue what I'm doing here. That should be painfully obvious by now. But I do think that this is an interesting method, and seems to solve what I was looking to do, which was identify at least a fairly reliable known reference voltage, aka Duracell AA batteries fresh out of the package. Identify a way to adjust the readout that the multimeter displays when connected to said Duracell batteries, and I think I met my objective. So if you're an expert in this field and you know of a better way that I can do it with this kind of DIY stuff that I have laying around the house, I would love to hear it. I know you can have it professionally done. I know that there are oscilloscopes and reference voltage apparatus that can be used. But I've kind of been a DIY, low budget sort of a guy. All my heli builds tend to go that way for the most part as well. So this seemed like a viable option. But again, if you've got better ideas, post a comment. Let me know what you got. I do appreciate it. And I guess that's it. Thanks for watching. Don't try this at home, and I'll catch you on the next one.